Welcome to Look Learn Lead. Kindly subscribe and press the bell button for updates. Hello everyone, in this video we will be discussing about access control and data link layer. Apart from these technical topics, we are also uploading videos on logical reasoning, quant and job alerts. So if you want timely notification, please subscribe to our channel. And now let's proceed on to our topic. Our topic would be containing access control protocols such as Aloha CSMA, CSMA CD and CA. Okay, so let's see what is access control. Okay, suppose we have two systems and they are connected by a point-to-point link. Suppose we have two systems and they are connected by a point-to-point link. Point-to-point link. That means this link is completely dedicated to these two systems. This link is completely dedicated to these two systems. At that time, access control is not needed. Access control is not needed. But what if we have a multi-point connection? Multi-point connection, that is we have five systems which are connected by a single link. Five systems which are connected by a single link, and all the systems want to transfer data within this link. Then we need access control. So let's first see when we need access control. Access control is needed when we have five systems and all these systems are connected with a single dedicated line, and all these systems want to use this link to send data. So then at that point of time we would be needing access control. Okay, this is what is access control. In data link layer we do two more things, that is error and flow control. Error and flow control. Okay, data link layer is responsible for these two things also. So there are three main responsibilities of data link layer, that is error control, flow control and access control. Okay, access control. So why is access control needed? That is when we have two or more systems sharing the same media and they want to send data simultaneously on this media. Then we need access control. Okay, now let us see how it is done and how it is achieved in our networking. Okay, so for access control, our data link layer is divided into two parts. Okay, they are divided into two sublayers. Let these be two sublayers, and the first sublayer, it is divided into two sublayers, and the first and the upper sublayer is called data link control, and the upper sublayer is called data link control, and this data link control is responsible for error and flow control. Error and flow control. Okay, and the lower layer is known as MAC layer. Okay, that is media access control layer. Okay, this layer is known as media access control layer, and this layer is responsible for access control. So what we have done is we have divided our whole data link layer into two parts, that is data link control and MAC layer. Okay, these are the two things. Okay, when we have point-to-point connection between devices, such as mesh, when we have a mesh network, okay, and we have point-to-point connection between all devices. When we have point-to-point connection between all devices, then only the first layer would work because there is no need of access control. No need of access control. But what if we have a single line and suppose four systems are connected to it? And four systems are connected to it. In this case, both layers would be needed. That is, access control is a must. Okay, so we will be further discussing about some access control protocols. Let's see what are they. The multiple access protocol, these all protocols, they operate at the MAC sublayer. MAC sublayer of data link layer. Okay, MAC sublayer of the data link layer. Okay, there are three types. First is the random access protocols. Okay, what is actually random access protocols is, in this we would treat all the systems equally. Suppose we have five systems. Three systems, okay, and they all are sharing a medium. Okay, so all three systems can send data at any time. Okay, they all are treated equal. Okay, that is called random access. They can send data randomly at any time. Okay, second is the controlled access protocol. What is controlled access protocol? In controlled access protocol, stations consult one another. If we have three stations, these stations would consult one another to find which station would be sending. Okay, there must be some reservation for this. for controlled access, stations they decide themselves at which station would send. And the last is the channelization protocol. In this, the available bandwidth, in this the bandwidth is divided. Bandwidth is shared. We can say the bandwidth is shared. How it is shared, we will be discussing. Okay, let's see the protocols and random access. There we have 4 protocols: Aloha CSMA, CSMA CA, that is collision avoidance, and CSMA CD, that is collision detection. Okay, we have 4. We would be mainly focusing on these 4 in this video. Okay, controlled access, we have reservation, polling, and token passing. Okay, for channelization we have frequency, time domain, and time domain multiple access, and code division multiple access. Time division, frequency division, code division. We have 3 of them, and we will be discussing it in our next video. Okay, in this video we will be discussing only the random access protocols. Okay, let's see our first protocol, that is Aloha. Aloha is the random access protocol, first random access protocol that we would be discussing. So, in Aloha, what is that? If you have suppose 2 stations and they are shared over a medium, they have 2 stations and they are shared over a medium, and every station would send data when it has, send its frame when it has frames to send. In data link layer, we will be talking about frames. Okay, so we all know that is a unit of propagation data link layer is frames. So if any station, if station 1 has a frame to send or station 2 has a frame to send, they would send the frame and they won't consult anything. They are both are equal. Okay, so let's see the shortcut of Aloha, that is the flow chart. Okay, here there are some terms which we should be familiar with. That is, K is the number of attempts. We would be using K somewhere. Okay, and TP is the propagation time. Propagation time means if there are 2 stations, T1 and S1 and S2, the time taken by the frame to reach station 2 and is the propagation time. It is a propagation time. Okay, so total round trip propagation would be 2 into TP, 2 into propagation time. Okay, that is, if a station send a frame F1 and to S2 and S2 send an acknowledgement, the time taken to receive acknowledgement would be 2p. Okay, 2 into the propagation time, and TB is the back of time. Okay, TB is the back of time. It is any random time. Okay, now let's see what it is. Okay, if suppose there are 2 stations, S1 and S2, or 3 stations, S1, S2 and S3. Okay, if station 1 has a frame to send, it would initialize its K is equal to 0. K is the number of attempts. The maximum attempts, K max is generally 15. So it can try 15 times. After 15th time, it can't send a frame. Okay, so first time it would initialize K to 0. So S initialize K to 0. Okay, K is equal to 0. And let's see when there is no problem in it, no collision or anything in it. Okay, what would happen when it, suppose 2 station, S1 has sent a frame to S2, S1 has sent the frame, it has received the acknowledgement. This is the exact perfect, it is the perfect situation. That is, it sent a frame and it received an acknowledgement. Okay, let's see what it is. Okay, S1 initialized K equal to 0. It send a frame is sent, and after sending the frame, it would be waiting for the timeout. The timeout is the round trip propagation, that is 2 into propagation time, that is receiving acknowledgement. If acknowledgement received, that means everything is perfect, it is success, that is frame has been sent. Okay, this is a perfect case. Suppose if frame acknowledgement is not received, here it should be no. If the acknowledgement is not received, what would it do? It would increase the attempt by 1. Okay, it would be the second attempt. So, and it would check if the attempt is greater than or less than K max. It has to be less than K max. If the attempt is greater than K max, then it can't send a frame. It would abort. If the attempt is less than K max, then it would choose a random number. Random number means any number, and that number is generated between 0 to 2 to the power K minus 1. Okay, where K is the number of attempts. Okay, any number between 0 to 2 to the power K minus 1, a random number is generated. Let that number be R, and it would multiply this random number into the propagation time. That is time taken by a frame to reach from S1 to S2. It is the propagation time. Okay, so it would generate a back of time. Back of time is equal to a random number into propagation time, and it would wait for that back of time, and again it would send the frame. Okay, this is what Aloha is. It would not ask the neighbors. It would just send the frame after waiting for timeout. If the acknowledgement not received, it would wait for a back off time and send. So here first case what we used is back off. We only used back off here. Okay, and sorry, acknowledgement and back off. First is acknowledgement and back off. Okay, if acknowledgement received, frame is successful. If acknowledgement not received, then I would wait for a back off time and send the frame. Okay, this is what Aloha is all about. Now second, let's move on to the next version of Aloha, that is CSMA. Okay, what is CSMA? It is carrier sense. Carrier sense. Now what is a carrier? Carrier sends multiple X's. Okay, this is Aloha, multiple X's. Now what is carrier sense? Carrier sense means sensing the medium. Suppose we have a medium and both station 1 and station 2 want to send data in this medium. It is a shared medium between these two, and these both would sense the medium first in this. Okay, there it was no sensing and nothing. There they both randomly sent. So there was no sensing. In this they would first sense the medium. If the medium is idle, then only the sender would send the data. Let's see its diagram. It is, there are three, in this there are three, that is one persistent. One persistent means it would check this channel and send. And it would surely send. Okay, if it is check this channel, if it is channel is idle, it would send. If a channel would busy, and it would again keeping on checking the channel. Suppose S1 want to send something to S2. Okay, so S1 what would do? It would busily check. It would keep on checking. It would keep on checking the channel. Okay, if the channel is busy, it won't send. Whenever the channel is idle, it send. Okay, in this case also there is a problem of collision. Collision means when two stations send the data at the same time. Suppose S1 is also sensing the channel. Channel is free. S2 is also sending the channel. Channel is free. Okay, but when S1 sends the channel, channel is idle, and at the same time S2 also sends and it is idle, and they both are sending. Then there is collision. It is one persistent. Okay. Now the next is non-persistent. In this what would do? S1 would wait for a random amount of time. Any time, random amount of time. There are two channels, S1, S2, S3. Three channels. Yeah, S1, S2, two channels. Okay. S1 want to send something. It has a frame to send. Even S2 has a frame to send. So S1 would wait for the random amount of time. So it is better than one persistent. But here also collision can be there. So it would sense the channel. Okay, if it is free, it would sense channel. It would sense the channel. If it is idle, then it would wait for random amount of time, random time. Wait random time. And then send. Okay, if it is idle, it will wait for random amount of time and send. Not free, it would wait for random amount of time, then send. Wait for random amount of time, then send. So this is called non-persistent. Okay, and the third one in CSMA CA is it is P persistent. Okay, this is, we can say it is one probability, probability 1. Okay, non-persistent means there is no probability involved. P persistent means it lies between 1 to 0. The probability lies between 1 to 0. Okay, so what would it do? It would sense the channel. Okay, if the channel is not free, channel is not idle, so it would keep on sensing the channel. If the channel is idle, okay, it would check the probability. It would check the probability of getting a slot in the channel. Okay, it would wait for a slot and then it would sense. So it is better than one persistent, 0 persistent. Okay, in this it would sense the channel 2 times, and after this it would send the frame. Here also it would send the frame. Okay, what it would do? It would sense the channel. If the channel is not idle, it keeps on sensing. Okay, if the channel is idle, it would check the probability outcome. If there is a probability of getting the channel, it would send the frame. If there is no probability of getting the channel, yes, probable, yes and no. Probability outcome positive, yes, positive. Okay, that would send it from. If the probability outcome is, it is like we can't get a slot, then it would wait for a slot and it would again sense the channel. Okay, again sends the channel, and if the channel is idle, it will say, it would send the frame, else it will again check the probability outcome. Okay, this is P persistent. This was all about CSMA CA. Next, move on to the another version. This is collision detection. Okay, See, collision detection, there is two things. First is when the collision has occurred, we have to resend the frame. Okay, so before resending the frame, we should know about the collision detection also. Okay, so let's see what is collision detection. Collision detection is whenever there are multiple access. Suppose two persons want to access the same channel, there would be some collision. Okay, so that is collision detection. So let's see what is collision detection, what happens when collision detection is there. Okay, in this also we would be talking about TB, that is back of time. Okay, which would be equal to random number into TP, and here also random number would range between 0 to 2k to the power 1. Okay, and here also we'll be talking about k max, it is generally equal to 15. Okay, and here in this what we would do, see, in this it is a combination of CSMA. So we would be applying persistent methods, any of the persistent methods plus collision detection. For transferring, it is we are doing two things. We are transferring, and at the same time we are detecting the collision also. Okay, see what here we are doing is we will first, k is the number of attempts, maximum attempt is 15. Okay, while first initialize, if S1 want to send something to S2, it first initialized k is equal to 0. Okay, and then apply one of the persistent methods. Okay, and it would check if it is eligible for transmitting. If it is eligible for transmission, then yes, if it is eligible for transmission and there is no collision, see the perfect case, k is 0, one of the persistent methods applied, it is eligible for transmission. If it has transmitted, yes, it has been transmitted. If there is any collision, see when collision occurs, if you have S1 and S2 and S3, both want to send data to S3, or S1 wants to send data to S4 and S3 want to send data to S3. Okay, and this is also sending a frame F1 and this is also sending a frame F1, F2, any frame. Okay, so when both are sending the frame and the frame gets overlapped, and this is called collision. Okay, the collision always occur after transmission. Okay, so collision detection is after transmission, after transmitting. After transmitting. Okay, that is collision detection. Collision detection is after transmitting, after transmission. Okay, so what we are doing is transmission, yes, the frame has been transmitted and then there is no collision, then it is a success. Okay, it is for collision detection. This whole thing is for collision detection. For collision avoidance, transmission, no, then transmit and receive. Transmit and receive. If transmission is not done, it would try to transmit again and again. Okay, if transmission is done, it would go for. If transmission not done, it would try to transmit it again and again. If transmission is done, it would try to detect collision. Collision, no success. If there is a collision, see here we are having what? The first is jamming signal. Jamming signal, you have to remember this, jamming signal. Okay, send a jamming signal. Okay, then it would increase k. Jamming signal means to tell that there is to check there is a collision. Okay, then it would increment k is equal to k plus 1. Number of attempt has been increased, and if k max has been reached, so it would abort, it can't send. If it is not reached, so it would the same, it would wait for random amount of time and back of time is calculated, and it would again try to resend. It is resend. Okay, this was all about CSMA CA. Collision detection is done when the transmission has already occurred. So here we are using jamming signal in CSMA CD. Let's move on to the another, that is CSMA CA, that is collision avoidance. Okay, in CSMA CA we will be using 3 stages. One is interframe space. Okay, and the next is contention window. Okay, I'll tell you what is contention window. I should have told you before only. Contention window, and third is acknowledgement. ACK. Okay, acknowledgement we all know. S1, S2 want to send data. If it is TP and it is returning time is TP, the total time is 2 into TP. The acknowledgement should be received within this time. This is the time to receive acknowledgement. Okay, this is what acknowledgement. What is contention window? The window we write from 0 to 2 to the power k minus 1. This is a contention window. Okay, in this we would be using interframe space. This is IFS. Okay, let's see what is collision avoidance. Okay, see. What would you doing is, first K is the number of attempts. We all know K is the number of attempts. It is equal to K max is generally 15. So K is number of attempts. Okay. First what we do? First we would see the perfect condition. Okay. K is equal to 0. Channel is idle. Yes. If channel is idle, I would be waiting for interframe space. Okay. Then I'll again check the channel. It is still idle. Then I will be waiting for random amount of time. This is called contention window. Contention window. Okay, here we are using interframe spaces, first and second, and we would choose and wait for all R slots. In this we would be waiting for all R slots, and then I would send the frame. Sorry, after sending the frame, wait for timeout. Timeout is 2 cross TP. Okay, after that is the time when his acknowledgement should be received. Within this time, we would say acknowledgement received. Yes, acknowledgement has been received. Then it is a success. Frame has been sent. Okay, now see the unidle case when we don't receive the acknowledgement. This is collision avoidance. So this would be before transmission. Before transmission. It is generally done in the case of wireless networks. Because in wired network it is easy to detect collision. In wireless network, collision detection is difficult. So we would be going for collision avoidance in wireless network. Okay, if the acknowledgement not received, then K is increased. We would check K is greater than 50. If it is yes, we would abort. Else we would go and check for the idle case. Okay, see this case is hold for checking the idle only. If it is idle or not. Here also we would be sensing if it is idle or not. If it is not idle, we would check it regularly. After waiting for interframe space, if still it is not idle, then it would go to the first thing only. So it is collision avoidance. We have talked here about 3 things, that is Aloha, okay, CSMA, CA, CD first and CA last, after that CA. Okay, in Aloha there was nothing. We just need to sense the channel and random amount of time we were there. So it is contention only was there. Okay, that is we were looking for random amount of time. No. So in CSMA we had 1 persistent, non-persistent and P persistent. Okay, in CSMA CD we were using CSMA whole, that is 1 persistent, non-persistent CSMA or everything, and we were using acknowledgement and contention window also here for collision detection. In CSMA CA we were using 3 things, that is interframe space, contention window. Sorry, in CSMA CD we were using jamming signal. Okay, in CSMA CA we were using IFS, contention window and acknowledgements. Okay, so this was all about, these all were random access control protocols. So this was all about random access control protocols. So stay tuned and kindly subscribe if you like this video. Thank you.